Okay, hi there, guys. My name's Raj. I am currently doing research. I'm a research engineer at Menlo AI, and basically what I'll be talking about would be the bitter lesson. Yeah, basically what are some things that I've learned along the way in my journey from creating startups to like working at one, while also maintaining and like withholding multiple open source projects. So yeah, a little bit about myself. I've built a few things. Some of the things that I've built might have been used by you guys. I created SG exams like really, really long time ago. And I've also made like a few apps that blew up back in my undergrad when I was in Singapore. And yeah, I've also won some of like the largest hackathons in the world, in the States, from CalHacks to Hack the North to a whole host of random like hacks that I took place when I was in like SF itself. I've also like been through 3Y Combinator interviews in my time in the States as well as when I was back in Singapore. I've also been rejected 3 times from the same interviews. And I think what I want to share with you guys are things that I've learned from those experiences. Oh, that's a rejection email if you ever get one. Yeah. Got them 3 times, it's insane. But yeah. Yeah, but that's okay, because I guess it did teach me a lot. Yeah, the first lesson that I learned and where I went wrong when I created that startup with my friend was that we actually created a novel diffusion model from scratch. We actually were not very new, we were very new to like training entire models and how model architectures worked from scratch. And it was tough, but we had the help of our friends in the Bay as well as techniques that people open source, like recipes on how to train models. So we actually learned a lot on how to generate synthetic data and how do we ensure that that synthetic data does not end up causing model collapse in a sense, because we were trying to showcase that we could train with very sparse data and create really high quality synthetic outputs that could then be used to detect basically new viruses or diseases that may come upon this world. One thing that we learned though was that the tech was not where we went wrong. It's really the contract that you have with hospitals and the healthcare world, which is that even if your tech is really novel and nice, it's actually very hard to break into very heavily legislated areas like healthcare law and legal tech, because the sales cycle itself is really long. It takes months or years for you to like even break in. And on top of that, there are high costs. You need, for example, since you're in the States, we had to fulfill SOC 2 and HIPAA before we even like got a client on board. And if you have no funds, it's very hard. So I guess that's one of the aims of all of these accelerators that exist in the world, which is to enable talented people like you to basically, yeah, just get a step in. I guess, yeah, which brings me to my second point, which is that, yeah, none of us were like from the medical space, we're like CS dudes, like, yeah, we were just like going at it. And we created a product that I think was novel. We even like almost submitted a paper. We didn't have evals and stuff, so we could not like publish it or whatever. But what we learned was that in this process of building this product, that there is a very big bitter lesson, that is that everything that was handcrafted, the architecture that we created was a very handwritten, optimized, like, I guess, model architecture that we created. If you put in enough data, and it does not really matter how much or how well your architecture looks, a company with a lot more data and better training, like GPUs or just a larger set of data, would be able to create a model that outperforms like really small handcrafted models. And I think that was a very good takeaway, because right after we got rejected, I think Google and one of the other labs released a Palm diffusion model that actually addressed like one of the prime areas that we were addressing, and we would have been destroyed if we actually like went in and entered that field during that time. Let me see why isn't. And I think what we also learned from this was that distribution was very important. It's like without a mechanism or a way for you to put your product, package it, and distribute it, it's likely gonna fail. Like, but that's why you should experiment a lot. Build as much as you can. Some things will fly, some things won't. And it wouldn't, and it's not wise to just create like features in your product. You have to create something that people want, and that's very hard to get. But then I think once you get it, you would see like the product that you're building accelerate way beyond anything that you have created. And I think it taught me something very important because I've always been technical. Human relations are very important when it comes to creating products or like starting a company. It is your moat against like bigger players because in this world, there is gonna be the case where big foundational labs would eventually create agents or products that might beat whatever offering you have, but they can't beat your personal connections with the people at hand. And yet, yeah, I don't know if it'll change in the future where you have like business deals that are like brokered by agents, but that's a whole different story. But back to the bitter lesson, right? What is it basically? If you guys have been in the AI space for long enough, you would know a certain person called Rich Sutton. He basically did like the TD paper, which basically talked about how like RL can be optimized. And what he said was that his learnings from like the 1970s and now is that everything that was handcrafted has been replaced by everything learned. And it's a lesson that keeps repeating itself. And I have a very like new example that I can showcase to you. So in my time, like last year, I was in Vancouver and I lived with a few researchers that worked on open-endedness. And basically, this is like the bitter lesson in your like in its true form. Like, so SweBench is a benchmark that's done for coding models to see how their performances are over time. And a lot of the initial techniques for SweBench were handcrafted. People created harnesses around them, around the coding models themselves. They gave them access to tools. They gave them the ability to create multiple agents, DAGs, or multiple handcrafted solutions. But what eventually won are the models themselves. Foundational models such as like, if you guys have used like Claude's like 4.5, it can one-shot a lot of your solutions. So it does showcase the power of not the power, more like it displays the bitter lesson where your handcrafted techniques would eventually be taken over by big, huge chunks of like just enormous data labs that have the ability to train really good models. And it also showcases another like interesting fact, which is that out of all of the models, there's a new benchmark that I did not add, which is the METR. It basically showcases how much productivity can an agent give back to the economy. And in that scoring, one thing that stood out the most was the Claude's 3.5 model, Anthropic's 3.5 Sonnet model, which basically showcased that it was able to create reasoning traces long enough to do economically viable tasks. And what that means is that general solutions that are inbuilt within foundation models have the ability to do general things even though they're not trained with them. It's a form of an emergent behavior that the models displayed. So another area that I do think will be very cool to look out for and add would be this space of world models. I actually did not finish the slide, but basically a world model such as like Genie 3, if you guys have read that paper as well, it's a paper from Google that showcases that they were able to simulate actual physical worlds based on data from YouTube as well as other data formats. And what's very interesting about that paper is that in that very paper, it showcased agents or beings that you can control with your WASD, like keys, and you basically have a game engine that's generated on the fly, which is insane because just think of it as the ability to create an entire environment with physical simulations that are running in real time. And if you guys have done RL, I think it's a real physical environment in which the entire environment changes. And that's really big because what that means is that you have the ability to create generalized agents. And what do I mean by that? There are a bunch of papers around this, such as Omni or OmniEpic, that display the ability of think of it as Dormammu and like Doctor Strange. If you guys have like watched it, you know how he like tries and tries again, even with different environments. The ability for him to eventually like say like for Dormammu to be like, yeah, like this is it, like stop. I think that was because the environment kept changing and he kept learning like different techniques on how to overcome that environment. That's basically something that a world model will enable us to do. An agent that understands spatial awareness. And what's more interesting is not only the agent itself, but how would the architecture inside that agent look like? It probably would not be handcrafted. It probably won't be like a fixed transformer model. It won't be like ResNets. It won't be anything. It might be something that could be very different from what we traditionally create or see as humans. And that I think is very interesting. Yeah, so that was a little side quest. But yeah, back to this. So I guess, yeah, there are other papers, if you have read like the DGM, which is the Darwin-Gödel machine, and ADAS, which basically show that you don't really have to retrain, pre-train or post-train models by simply enabling models to have an understanding of a so there's this technique called like RLVL, which is on verified functions. You can basically train agents. Verified functions in this case being code. Code itself is a very nice verifiable function. And in that, you can basically create really interesting and nice mechanisms to create these agents and give these agents the tools that it creates itself to become better at coding. And basically, the DGM paper showcased that, in which it showed improvements from 20%, from the agent scoring 20% on the SWE bench to scoring over 50%. Yeah. So I think we're also in this age where pre-training things from scratch, if you do not have the compute, are things that are not necessary, but it will lead to higher optimals until the benchmarks are saturated. So yeah, just a few little things on what you can learn from my bitter lessons too, which is that even though you're like, you know what you want to solve, I don't think you should like just leverage or push or be very proud of your technical capabilities. Sometimes the most like, the best solution to problems is very simple. Yeah, and I feel like from the products that I've built that have worked, it's really that you think of distribution as infrastructure, not like the other way around. And that's very important because if you think of your product scaling up to, say, tens or millions of users, how do you get there? Then you worry about the technical problems because getting there is hard, yeah. And if you are going to handcraft that solution, like be very well aware and very sure that you have that distribution for it. But at the same time, you are also an agent, right? You can try as many times as you want. You can fail as many times as you want. There could be something that you're very passionate about that you might end up creating that basically, yeah, I think you can just like, yeah, you're a recursive agent and you might also win that way by brute forcing it. So let me skip this. Yeah. So for me, I have contributed a lot to open source code. I think what is very interesting is that a lot of our current compute is centralized. It's good, it's efficient. Centralized compute enables us to create really interesting and really efficient model architectures as well as structures. But if we extrapolate that a little bit and we go into a world where hell, the METR benchmark is oversaturated, then what would you guys do, right? If companies can hire agents to code for them, this whole room is cooked. Like, yeah. So I think with that in mind, it also would create this little vacuum for innovation. Like, it's fully centralized. A few companies own it. How are you going to be a part of it? So, and they've also been training on their own centralized data stores that they get from various data companies like Scale or like DataCurve. Basically, what I believe is that like having a decentralized open source community will create more novel solutions, as you have seen. Model companies that have released open source models as well, like Mistral, Qwen, your Kimi, yeah, there's a whole bunch of them. But this enables people and researchers to explore solutions to problems that even closed companies may not have the answers to. Like you have seen very interesting things that closed model companies have also used, like Yarn and other stuff. So I think, yeah, having a open source initiative would be very cool. So yeah, I guess now is the part of the talk where I'll just like briefly talk about my own open source contributions and explorations. Um, I basically made one of the fastest type validators for Python. It's called Satya. I made it like a few months ago, and now it's one of the top most downloaded packages on Python ever, like in the top 10% quartile. Um, I think with that, for this, I think what problem it addressed was really for me to ingest large amounts of data. There was no solution that was fast enough or parallelized enough. And so I just made my own, yeah. And I think it resonated with people too. So they started using it and yeah, it kind of like had that network effect and it enabled it to blow up a little. I just made this a few days ago on a weekend because I didn't like Zod. If you guys have used Zod before, it's just another TypeScript validator because I'm like, I'm good at validators, so why not? So I actually made it. It's not built for production yet, but you can actually just like, it's officially on one of the official TypeScript benchmarks as well. Yeah, as being significantly faster than like Zod itself. And I built that with Zig, if you guys know what Zig is as well. So yeah, and this week, like, yeah, the GIL was lifted. If you've heard, like, Python's global interpreter lock. If you guys use Python, okay, never mind. Yeah, but it's a big thing because now you can do multi-threaded things on Python, and that is very cool because I just shipped an alternative to Fast API that sort of semi-blew up on Twitter, and basically I bundled it together with things like, what do you call that? With Hyper as well as like Tokio. So basically it's using Hyper under the hood and it's managing all of the Multex contexts and it's enabling you to spin up multiple workers at the same time, which enables it to basically ingest a lot more requests a second. And it turned out as a side project, but I realized that a lot of people are actually using it as well. Like just in a few days, like the download count increased to a few thousand. So yeah, I'm like actively working on this now to just see how it goes. And it's using like the validator that I created under the hood as well, because Pydantic is slow and Fast API uses that. So yeah, that was another side quest. Oh, another side quest too. But basically, I made this as a library. It's called Boomi. I hated like LLM, and I was like, there should be a way to make it faster. And I actually used like open-ended techniques. The reason why it's so fast is that it is PyOpt via an FFI to the Python, like, this was back when the GIL was like in effect. It basically allowed you to multi-thread your LLM requests. And in the cache buffer itself, I used a optimizer that was sort of not trained, but more like grid archive optimized using a technique called map elites, if you have ever read of that paper as well. And it enabled it to process and allocate chunk and buffer sizes way more effectively for each core that's on the computer, if you guys also get that. Yeah, Muonri, and then yeah, I just made a code editor for fun from scratch, like Windsurf, but you guys could try it out maybe like sometime. I don't know, if whenever it comes out. And the most recent thing that I built was actually a whole database from scratch that I gave a talk on at AI Tinkerers. It's actually like just civdb.dev. It's kind of live right now. I'm not sure if I should open source it because it works really well. Basically, it can search code. I can just show a live demo of it. But basically, what's really cool about it is that you can just put in any code base that you want. And I realized that the most general solution is not having a semantic-based embedding model like what DeepWiki does, but instead it's rather enabling agents to search with regex-based methods like grep or grep, I don't know what you call it, but grep or like SEDs, and you're then able to find out files way faster. The contribution from this was basically having a pre-indexed tree that basically worked really fast. It adapted to different ASTs that languages use. If your program is broken, I'm not sure how it will work because the AST is pretty important. Like if you have functions that don't go anywhere, yeah, I'm not sure how that would perform. But yeah, I built that for fun as well. It will be an MC. It is an MCP, but I'm on the fence on whether or not I should open source this thing too. But yeah, I guess like that's about it. I don't know if I have a lot of time. Yeah, but yeah, I didn't plan this talk to be very long too. Yeah, so yeah, that's me. Thank you. Yeah, thanks.
Anybody have any questions? How old are you?
Sorry,
How old are you?
I'm 25. Yeah.
What inspired you to create all of these?
Sorry.
What inspired you to create all of
Oh, vibes.
all five? Right. Well, 专业 actually, but I mean, aside to the vibes, I mean, like, you just woke up and then got out of the bed, and you're like, I want this.
Oh, well, that's a good question. Not really. I think so. I do build a lot of products. I do have a lot of products that I've built, and some of them are revenue generating. And I think Satel and Boomi were built to address one of them. Um, it was basically an SEO agent that enabled a few companies to rank themselves really well on the search index. And I think one of the biggest bottlenecks was like agent calls, because I wrote that whole backend in Python, which I think it's okay because you're just prototyping things. And that then enabled or inspired me to create Boomi. But then for Boomi, the bottleneck then became the validator. So I made Saten a day to address that, and that's how we got these two libraries. Yeah, and the Turbo API is a very recent thing because I was like, why not? What if I rewrite Starlet in Rust? How would that look? So that's how you got that. Yeah. Yeah. You're up. Yeah.
Can you elaborate more on Symphony?
Oh, sure. Like the code or?
No, like, how does it work and what does it do exactly?
Okay. I think I can just share the. Um, yeah, this is like basically it. I mean, it's very simple in a sense that if you know Rust, like what it does is that it basically ingests code, like entire code bases. And the way that it does that is that I created my own file format because you know how databases work. They have their own like fixed file formats with different files. So I created a .stift file format, which is a compressed file. What the ingest method does is that it basically takes in a repository, splits it by files, finds out what files are needed and not, because there's a lot of like markdowns and stuff that may not be that like geared towards coding. So it removes them, it does a quick profile, and then it compresses that code base from the algorithm that's I used a few of them, but then I did trial and error with a bunch of them. And once it's compressed, I then had to create indexes as well. So 3 indexes as well as uh, what's the other? But yeah, basically a bunch of indexes. And then once these indexes were in place, when the database is loaded, it's loaded to the RAM. So it's really fast. Like when you do a query or a search or a get request from the database, you can either search code snippets. Once you get the code snippets, you can also get the entire file from where that snippet's from. So it mimics the behavior of coding agents, whereby they sometimes do grep. And then when they grep and they find like a certain file number and line number of that code, they then just read the entire file. So it mimics that behavior, but inside the database. So the agent doesn't do any of that. Your computer doesn't do any of that. The database handles all of that logic, like that business logic. Yeah. Yeah.
Yeah, thanks.
Yeah. Mm-hmm.
And the second question is how to become a 10x in Rust? Like,
Oh, what?
how to become a 10x there in Rust? Like,
Oh, I don't think I'm 10. I'm just doing it for fun. But yeah.
how to get
Uh,
what's your, how do you get comfortable with Rust? Yeah.
I think for me it's like I don't think languages matter a lot. I really think it's what you're building matters. And I just realized that for some of them Rust was easier, while for others Python's better. Like if you're doing a server with like a lot of users, Golang might be better because you have coroutines and stuff like that. So I feel like you shouldn't be constrained to languages, but more of what your end solution's gonna be. Languages are just a means to get there. But I feel for Rust, if you really do want to like pick it up, I think right now with AI or like Claude or ChatGPT or Codex, I think Rust becomes a lot more easier to learn because it has a compiler inbuilt. So if it makes mistakes, you can actually see where it's going wrong. You can look at the reasoning traces of the model as well. What is it trying to like talk to itself with? Because it's been sort of like accustomed to that human in the loop training. And then from there, you can actually understand like, oh, this is like what it's thinking of. Like, oh, it's a Maltex error. I'm like assigning the wrong pointer to this like variable. Like, I should do this instead. So I think, yeah, over time you would get accustomed to the workings of a language, and I think it really helps if that language is like compiler proof. Like it has a very nice compiler that runs at runtime itself. For your first, what was the first question though? Oh, good question. So I think at the start, I wanted to make a open sort of non-paywalled way to access DeepWiki. I even bought a domain for like wiki.codes. I have a shitload of domains, but basically the idea was how do I do this very cheap and like make it scalable for people. So there are no semantic like embeddings or whatever. It's purely like regex heavy, so grep-ish in a sense, but not entirely grep because grep is not great for like large scale operations. If you have like say 10 million rows, like grep is gonna give you like a shitload of like code snippets, right? So what you do is you sort of tune it towards the languages that it uses. So this like database is tuned to the most popular languages like Rust, like Python, TypeScript, JavaScript, which is like your main languages, but they do have a very similar syntax. So that way there are pre-filled like index variables that are like more optimized for as well, which like exists in another enum of like indexes. So it does it that way. Yeah. I mean, for anything, if I have time, like I can even show you guys how it works in real time. I have indexed like Codex, I think. Let me just see if I can create a new window. And then maybe let's just open this. Yeah, let's just start this from scratch. So I'll just redo this. So I just tell it to like utilize the CivDB, which is an MCP tool. It just lists out entire code bases like React, Satya, Codex, and Virl. Oh, Virl is a really good library if you're in ML. But yeah, that's how fast it searches code. It realizes what the code is, and then it sort of like just will read entire files as well. Yeah, so it's basically doing what a normal agent does in a predefined environment. And this thing is like live too. If you guys want to like use it now, you could. Like I have tunneled my laptop through Cloudflare. Yeah. It's like, yeah, this is like the URL. If you guys are like, yeah, you can just try it out on your own like code editors. If you guys want to like play, it's running on my computer. So yeah, it'll be live for a while until I turn it off. But yeah, so you can see on the side that it's actually like, it actually did like read entire files as well. Like it read how the codex result looks like. It's like a bidirectional method to have interactions with users. And yeah, it'll just create a naive coding agent. So yeah, it works really, really fast. It works locally as well, as it's like literally running on my computer. But yeah. So that's a quick gist of it. Yeah.
Have you considered using this type of framework or maybe any other framework for RAG-based solutions?
Oh, good question. Actually, I've not. And I think it may not necessarily work too for RAG because it depends on what kind of RAG. For coding stuff, like you can't really use semantics because the embeddings themselves, the way that they were trained, probably would not capture the semantics that code has. But I think for RAG, it also depends on what kind of RAG it is. Is it a storybook? If it's a storybook, I think this will work really well because at the end of the day, you can even use like BM25 and like get your data out by just a very simple retrieval step. But if it's something more nuanced, like if you're going through a report paper, for example, if you search something like a document of that size with this, I think it won't be very efficient because it would not understand the semantics of that paper itself. Because more likely than not, the bigger embedding models have been pre-trained with those sort of reports and books, and they would perform better. I would say I have not tried, so I wouldn't know. Maybe this does perform better, but yeah, I don't know. Yeah, for coding, yes, though. Yeah, definitely. Yeah, yeah.
Simulation, physical simulation. So have you ever tried anything related to that?
Sorry.
Have you ever tried any kind of product related to the kind of training AI?
Oh, I actually did a little. I worked on it with someone I knew. Like, yeah. We used Isaac Sim for that. We sort of did policy training on a Unitary H1 robot. I think what we were trying to see was that if we change environments for that robot, how would it perform? We never really got to finish that like experiment though, because things happen. And yeah, but I think what's interesting is that so like I said, open source decentralization, like the decentralization of technology is important. So labs like if I'm not wrong, the Tencent's like Huan Yu, I don't know how to pronounce it, but yeah, that lab did release a similar world model environment that was based off their own image models and their own video generator model called One. So it stitched them together, and I think if you have the compute, you can like probably play with that. Yeah, yeah. Yep. We could try seeing if it works though. I don't know if the coding agent's gonna work. But do we have time?
Yeah, we have like 30, 45.
Okay, but okay, I don't even know if it's gonna work though. It one-shotted it for all. Let's just create an end file. Let me just quickly get a few. Yeah, I guess it's sort of working. Yeah. So yeah, basically this just read through the whole. It created a planning agent as well. Yeah, it read through the Codex database and it one-shotted a coding agent. So, yeah, yeah, you go. I guess I don't know what else to say. Yeah.
So you said you're like actually like reading through the files and parsing and identifying variable names and stuff.
Yeah, correct. That's right. Yeah, so you could like, if you look at the traces as well, you can actually see it do just that. It started out searching code. It was trying to find out main code. I don't know why, but it was finding out definitions, classes, main objects, and where agent was like set, because then agents use tool, and then it probably read the whole file for how chat completions work, and then it just viewed another file for how the agent works, and then it just went on seeing how its conversations work, how it manages conversations, how does it execute turn-based code, and yeah, it basically one-shotted that. I think it is not as complicated as it is, but it's crazy that you can one-shot coding agents on your CLI with things like this now. Yeah. So, yeah.
I have a quick question. Like, you've done a lot of open source libraries and stuff, right? When you make a new library, like, how do you get people to try it out and get a little bit of, feedback going? Because usually just me and my friends trying it out.
Right,
Yeah.
right.
How do you distribute?
I think for me, initially it was very like it was just for myself. Like I'll probably have an actual business case that requires it, and then I'll build it out for that. And then I guess it's also attending events and then talking about the library itself at hand. It also helps that like I have friends, as in, yeah, I guess Twitter and like LinkedIn help. I've not used LinkedIn in really, really long, but like I would assume they help in distribution. I've not needed that anymore, but yeah, I think over time it's a network effect. So I think it grows like as you put yourself out more and you just try shit, I guess. Like, yeah, yeah. So yeah, thank you for that question too. Yeah. Oh yeah.
How do you review code when it's one short while like thousands of lines of code? Will it add bundle to your development?
Sorry.
So you just do a coding agent, right?
Mhm.
So when the coding agent one shot, usually it will write thousands of lines of code. So do you think that it will increase your productivity or not? Because you usually take our effort to review the code, right? So how do you balance the what you get and what you pay?
Oh, that's a good question. Yeah, I think for me it's okay because I grew up like not I'm not that old, but I was there at a time when it was pre GPT, right? You didn't have like these things like spewing out code. So I think it enabled me to like understand and read through code a lot faster and understand like what's right, what's wrong. Like you can eyeball it, but I feel like maybe I don't know how you guys code at all. Like you guys may code completely differently from how I code. But I think yeah, it's important to understand the syntaxes. You would kind of figure out when it's wrong as it's coding it out. So you can actually see the traces of the agent, which I do look, which is why I don't use CLIs. I prefer like IDEs so that I can like see the code, what's the diff, what's it trying to implement. I think you can supplement that with test cases, which is very critical. So you, oh, but I think some models are bad because they'll just make a shit like test case that passes with their code. Yeah. So I think we are not there yet where you can fully hands off your solutioning to an agent. But I think like the bitter lesson itself, right? I don't think we're very far away from that, and which makes it very scary because then what happens to us? Yeah. Yeah. So yeah.
How about it? Can I come in? So this product, right, because I went to the website, it seems like some of the functions are not clickable, so I guess it's not in production.
Oh yeah, it's not.
Right,
Isn't that website's white coded?
So yeah. So once it goes into production, what is your plan for this? Like, is it gonna be enterprise graded, like open source? People like us, the small people like us cannot use it anymore. It must be the big enterprise, right? Like, can we still use it?
I think it'll be free for like all the open source code repos. I haven't thought a lot about like what to do with it. I built it for fun. I think I realized it has a lot more potential than what I started out like it with. I mean, it's my first time building a database from scratch. I didn't have a lot of expectations.
We all do. So if you were to commercialize it, right? What model will you commercialize it?
Ooh, I'm not too sure about that. I've not thought that far into it. I mean, it's a vibe fun project for me.
I can see the vibe.
Yeah, so I think it's more like I had fun building it out. I feel like you shouldn't gear it towards money at the very start because you may lose the innate desire to build if you like gear it towards money. I think money would come to you eventually. Like it's not hard to make money if you like what you do. Yeah. 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 Thank you. Yeah. I think that's about it though. Yeah.